So the first way to solve a system is by graphing. First way is to graph. The other two ways are substitution and elimination. Those are algebraic methods. You'll use those more than graphing, of course, but graphing is one way to do it. So if you are solving by graphing, there are three ways that your answer will show itself. So one, you graph both of your equations and the lines intersect. So if the lines intersect, that means you're going to have one solution, and then the answer will be whatever point they intersect. If you have one line on the graph, then that's called infinitely many solutions. So you would literally give that as your answer. Infinitely many solutions. So I know some teachers will accept IMS. Feel free to give the abbreviation as well. Or both of your lines, you graph both of your lines and you see that they're parallel. That's no solution. So you literally would put no solution. Now, the majority of the time, the lines are going to intersect. But since the other two exist, you might as well at least know that they exist. Any questions before we start with our first example? Again, these are your three possibilities. One solution, they intersect. Infinitely many solutions, you have two of the same line. No solution, the two lines are parallel. So let's do a very basic example of a system. So y equals 3 and x equals -5. So you have a horizontal line with a vertical line. Horizontal line with a vertical line. So this is very, very similar to what was on your test. So the question that was on your test was graph the vertical line, graph the horizontal line, and tell where did they meet. This is literally the exact same problem. So when we graph, first step, rewrite the equation into slope-intercept form. We don't need to for this problem. Then, grab the first equation. So y equals 3 is a horizontal line. So that means go to the y-axis, put your point on 3, and then draw the horizontal line. That was the main thing that most people did wrong on the test with this type of problem. You put the point in the right place, you just didn't draw the line. But yes, you have to draw the line. Now we graph the second equation. X equals -5. Go to the x-axis. Go to -5. Draw your horizontal, or draw your vertical line. So there's your horizontal line, there's your vertical line. Notice that they intersect right there. So the only thing you have to do, since they intersect, is to tell where did they meet. So all you're identifying is the point where they met. That's -5 on the x side, 3 on the y side. There's your solution. So it's as simple as that. Draw each line, and if they meet, tell where they intersect. Any questions with the example number 1? All right. So of course, all of your lines are not going to be horizontal and vertical. So let's do some slanted lines. So your slanted lines means y equals mx plus b is coming into play. So we've done a lot with y equals mx plus b. So y equals -4x plus 8. Y equals 2/3 x minus 6. So first order of business, graph the equation. Graph each equation. So again, identify the slope. So -4/1. Identify your y-intercept. There's your slope, there's your y-intercept. Remember, y-intercept goes on the graph first. Go to the y-axis, put your point on 8. So your slope is negative. Remember, if you have a negative slope, you go down and to the right. So 1, 2, 3, 4, to the right 1, put another point. 1, 2, 3, 4, to the right 1, put another point. So you only need 2 points to draw a line. I just kept going because I want my line to be straight. Any questions before we continue? Again, if it's something you don't understand or doesn't quite click, you gotta say something. Remember, high school career is just about over. You're adults now. So now it's really cool now it's gonna get there. So go to the second equation. 2 over 3x minus 6. So again, it's already in slope-intercept form. We can pull it right off the graph and move it right out the equation. Same rules apply. Go to the y-axis, put a dot on -6. this time your slope is positive. So positive slope means you go up and to the right. So go back to your -6, go up 2, to the right 3. What's your point? Sorry, right. So there's your two lines. As you can see once again, we meet right there. Since the lines meet, we just have to identify where it is. So let me give a few seconds for those who are looking on the screen to count the spaces to figure out where it is. And it looks like it's at 1, 2, 3, 3 for x, 1, 2, 3, 4, -4 for y. So 3 comma -4. Like reading coordinates off of a map. So just like we did on Monday, if you want to know if you got the correct answer, take 3 and -4, plug it into the equations that you started with, and they should match. If they don't match, then it's not right. Don't match, not right. Any questions, 1 or 2? Yeah. It's not hard, it's just a little bit of work. All right. So let me give you a chance to start one yourself. So example 3, same type of problem, same type of situation. So let me give you a couple minutes to start example number 3. Let's navigate example 3. So y equals -2x minus 3 and 6x minus 3y equals -15. So we still solve the problem the exact same way we did with example 1 and 2. So the first equation is already in slope-intercept form. Pull the slope off, pull the y-intercept off. So it's already set and ready to go for us. Y-intercept's -3. Down 2 to the right 1. Now, since I have all this space up above, so remember for a negative slope, so if your slope is negative, you can go down and to the right, but you can also go up and to the left. It will still work the same way. So up 2 to the left 1. Go both ways? You said, do you have to draw it both ways? You don't have to. I do it, one, so that my line is straight, and two, if I can force the points to lay on top of each other, then it makes it easier for me to solve the problem. That's the way that I've done it essentially all my life. If you only want to do it one way, that's fine. That's just more so personal preference. So there's our first equation. Second equation. What do we have to do first? You can't graph that yet. So something has to happen to this before we can start that problem. So you can get the x and y-intercepts, or you can put it, move this x to the other side. 3y equals negative 6x minus 15, and then divide everything by negative 3. So y equals 2x plus 5. So the first thing we had to do put equation into y equals mx plus b format. So yeah, sometimes you gotta do a little lifting, a little heavy lifting before you can graph your equation. But now everything works itself out. The slope is 2. The y-intercept is 5. Go to your y-axis, put a dot on 5. So your slope is positive. So remember, positive slope is up and to the right. Or you can go down and to the left. So just as Steve asked, you are not required to go the other direction. But with me going the other direction, I now got the points to fall on top of each other. I got the points to fall on top of each other. So I know exactly where these equations meet now. I know exactly where they meet. I don't have to guess at it. I know exactly which points fell on top of each other. Negative 2, comma 1. Negative 2, comma 1, and that's it. So again, the main point is you want to do it right the first time so that you don't have to do it over. You want to do it right the first time so you don't have to do it over. Any questions with example 3? All right. So as I said earlier, the majority of the time, your two lines are going to cross each other. That means your answer will be a point. But there are some times in which the lines won't meet, or you'll only see one line on the graph. So let's look at those two special cases. So our last two examples are of those two special cases. So, first special case. Y equals negative 3 over 2x plus 1. 3x plus 2y equals 10. So, first equation, y equals negative 3 over 2x plus 1. It's already in slope-intercept form. It's already in slope-intercept form, so here's your slope, there's your y-intercept. Carrington, I see you were able to get in. Don't worry, the notes get recorded, so you can always check them out later. And just pick up from where we're at now. So there's your slope, there's your y-intercept, go to your y-axis. Y-intercept goes on the graph first. Negative 3 over 2 means down 3 to the right 2. And you can always go up 3 and to the left 2. So first equation, it's already set up for us, so we're good to go. Second equation is not set up for us. So this has to get rewritten before we can proceed. So how do we rewrite this? You can't graph that until it's rewritten. How are we going to rewrite this problem? Not knock anyone home. How do we rewrite this problem? All right, so 3x has to move. So 2y equals negative 3x plus 10. All right, so I got the 3x moved over. Divide by 2. So y equals negative 3 over 2x plus 5. So now the equations are rewritten. So there's your slope. Oh, look at that. Slopes are the same. Y-intercept is 5. So now we can go ahead and graph. So your slope is down 3 to right 2. There's our two lines. What do you see? Do you see what I see? They're parallel to each other. So, since these are parallel, this is no solution. Parallel lines have no solution because they will never touch each other. So, no solution. Parallel lines never touch each other, so you have no solution. So here is the shortcut to figuring that out. If your lines have the same slope, which these did, but different y-intercepts, then you have no solution. So you got to take a placement test for military or place it into your classes for next year. Again, most of your placement tests are timed. And for most of your placement tests, you're not allowed to use a calculator. So that means you have to know the actual content. Remember, ultimately, one of the overarching goals of this class is to make sure that you don't have to take a class like this again in college. In college, if you take a class like this, most of the time they represent those as remedial classes. They don't give you college credit for remedial classes. When you're giving the college money. That's not a two-way street. You're just paying teachers like me to teach the class. Questions on example 4? Before you our last example. So of course, since I said we were going to do one of each type, then you should know that this answer is going to be infinitely many solutions. But you might as well see why and how that exists. See why and see how that exists. So, I'm going to give you a moment to start the problem. Knock this last one out. All right, so you have your two equations. So the same rules apply. So, just as what was already mentioned, no one said you had to start with the top equation. You do it whichever order you want. So if you did the bottom equation first, just to get it out the way, okay. Y equals negative 5x minus 2. So your slope is negative 5. Your y-intercept is negative 2. Go to the y-axis, put a dot on negative 2. Down 5 to the right 1. Or you can go up 5 and to the left 1. So there's the first equation. So the second equation, I can't avoid it anymore. I have to rewrite it. So in rewriting it, the x has to move to the other side. divided by negative 2. So y equals negative 5x minus 2. So what do you notice? What do you see? You don't have to be Ray Charles to see what this is. They're the same exact equation. They match up 100% exactly. The slope is still negative 5 over 1. The slope is still, and the y-intercept is still negative 2. It's the exact same equation. So why am I about to graph the same thing twice? Doesn't make sense. I have the same equation. So that means whenever you have the same slope and the same y-intercept, basically two of the same equation, then your system has infinitely many solutions. Or you can write it as IMS. If you have two of the same equation, it's infinitely many solutions. You might have to do a little work to see that that's actually the case. But two of the same equation, infinitely many solutions. There you go. You keep it moving. So, questions on example 5? Okay. It's not hard. Y'all aren't doing anything that y'all haven't done before already. It's definitely not hard. So when you graph each equation. Well, put it in slope-intercept form first. Graph each equation. If the lines intersect, then just tell what the intersection is. If the lines are parallel, then you have no solution. If the lines lay on top of each other, then your answer is infinitely many solutions. So it's got to be one of those three answers. If the lines are intersecting twice, you did something wrong. Lines should only intersect once if they're going to intersect at all. So, any questions before we get ready to wrap things up on this wonderful spring day?